And inevitably, you always get the twin question, right? So here is an example of my twin, okay? I'm not going to tell you if I really have one or not, but this is him, okay? So what inevitably a client will want is they'll say, hey, I want you to be able to tell me the difference between me up there and my twin.
Mm-hmm.
And not only that, I want you to get everything else right too, right? So you're basically asking the matching algorithm to give me a 3.5 in comparison to my threshold for this image, and yet still give me a 5.5 for the guy below in the second row there. Now, is that realistic? That doesn't, that if you think about it, that doesn't make any sense at all, right? And so that's why ultimately it does come down to quality, right? And consistency of quality. So false non-match rate really only makes sense if you're talking about the same quality of data, right? And that's why NIST tests for similar quality of data, right? So you see tests in NIST for Visa, tests for Buckshot, tests for Wild.
Mm-hmm.
There are even twins tests, right? Specifically because the quality is sufficiently uniform that false non-match rate then means something, right? But in the general case, false non-match rate doesn't really mean that much, right? And you can't even tell somebody, how accurate is it? So somebody asks you, how accurate is it? You have to ask the question, well, I don't know, what's the quality of your database? How uniform is the quality? These are all relevant questions, and so there's very rarely sort of this simple answer to biometrics, because there are these nuances to understanding how the system works and how all these things interrelate with each other.